So question 4. We have some givens, and so they are the mass, which is 110 kilograms, and we also have the height the skier initially starts at, which is 210 meters. And so part A is asking us to find the work. So it's important to remember that the work is actually equal to the gravitational potential energy, because it's asking us the work that the gravity does on the skier as he makes his way down. So this is important to remember. And then finding work actually becomes quite simple. We know that the gravitational potential energy is equal to this mass into gravity into delta y. So we can write work is equal to mass into gravity into delta y. And then in the end, we can simply solve. So 110 times 9.8 times 210. And so the work in the end is equal to 2.3 times 10 to the power 5 joules. And again, I'm writing in two significant digits. Now, part B is asking us to find the velocity when the skier reaches the bottom. And so again, there is no friction in this problem, so it's important to remember that energy is conserved. So I'm kind of putting this in stars as well, because that's important to remember. So what that means is that the gravitational potential energy in this system before is equal to the kinetic energy in the system after. So we know the gravitational potential energy is decreasing, and we know that the kinetic energy is actually increasing. So he's speeding up as he goes down the ramp. So we can write that as EK. So that means this is positive and this one's negative. So kinetic energy minus gravitational potential energy, giving us 0. Then we'll simply expand zero. We'll move this to the other side. And actually, we don't need to calculate this because we found it here. Remember? We found it here. So we can write 2.3 is equal, 2.3 times 10 to the power 5 is equal to 1 over 2 mv squared. We'll plug in what we know. Divide both by 0.5 times 110, 0.5. And then we'll also root both of these just to get rid of that root over here on top of the velocity. And so in the end, the velocity you get should be 65 meters per second. So therefore, at the bottom, the velocity is 65 meters per second.